bring this down a little. All right. So there's a couple of things that you want to be able to do, but if you think back to what we've covered in this course, we've worked with a lot of concepts related to linear equations. All right, and so that's writing the equation of a line, for example, or graphing lines, things of that nature. All right, so in the past unit, we worked on different types of functions. All right, identifying whether something was a function, evaluating the functions, and so on. All right, so what we're going to do, and I'll just give you a little taste of what the project's going to be about. Essentially, I'm going to give you a graph. All right, if you think back to the quiz, I still, by the way, if anybody's wondering, I'm still grading those, and also there's still some folks that have to take it, so that's what the delay is there. But if you think back to the last question or set of questions where you were given a graph and you had to write a narrative related to that graph, it's basically what you're going to be expected to do with this project, except you're going to create an animation. All right. But what you need to actually have happen is a character move along your graph. All right. Since it's made up of linear equations, it's a nice opportunity to incorporate writing the equation of a line using block coding. All right. Now, there's things like particular motion functions like glide and stuff like that go to. We don't want to do that. We actually want to define variables. We want to actually have a linear equation that maps the movement of the line or the object along the line. All right. So what I'll do here is first I'm going to get rid of their preloaded stuff because we want everything that we do to be original. All right. So, you know, when you put a sprite in, we don't want to go to one of theirs. You know, we want to choose we want to create our own. All right, and so what we could do is we can upload one. We can go to, I mean, within reason, you know, like you can go to like Google Images and stuff like that. You don't have to draw it by hand, but if you do have some artistic ability, then you know coming up with a truly original character would be really nice. All right, so we know how to do that with the paint function. We don't want to do anything that's preloaded. All right. So if you go into the paint function and you decide you want to do a character, now you'll see my artistic ability. Oh, actually, let me increase the size here. Let's go to, yeah, I'm thinking like 20 is probably where I want it. Yeah, something substantial. So then I can dial it back down so I can get the features in there. Oh, one eye is bigger than the other. Yeah, look at that character. All right. So I got my character. So he's way too big. So I go to my size option, reduce him in size. I got a little guy. All right, maybe a little too little, too big. You know, you play around with it. You know, so there's that option. Another option would be to go to images. You know, Google Images, and figure out what kind of character you want to have. I don't know. I'm just trying to think. Oh, maybe Olympic fencer. I don't need the screaming, crying stuff. Let's see here. Oh, I know that guy. Let's see here. I'm just looking for one that, like, in the classic pose. This one might be all right. Save image. Sensor. Save. Okay, then I go back to my scratch. I'm gonna upload my sprite. All right, I believe I saved it to my desktop. Open. It's way too big, but then I go into the costume function. And then I just start erasing stuff, whatever I don't want. So I only wanted the part of the fencer that showed the attack. Obviously I'm doing this pretty quick, so it isn't going to be pretty, but I'm gonna leave that little outline because you can get in there a little closer and really get those pixels taken care of, but I don't know that time-wise I really want to get into that. Yeah.
You could use like a PNG photo, right, where you don't have to erase the background.
You could do that if it's available.
Yeah. Okay. Thank you.
No problem. All right, so let's say I'm going with that route, bring it down to 40. It's a little, like I said, a little choppy, but I got my characters here. So what I want to do is I want to have a linear path, all right? So let's say I want to have this one move along some sort of line going from the lower right to upper left, and let's say I want this one to go from lower left to upper right. All right, I'm just going to create a quick line, a set of lines for that. I started doing this already, but it's something like that. So I'd put that in as my backdrop. All right, so upload. That's a screenshot. So now I have my backdrop. So let's say I want it to go along this path here. All right, I want my fencer to go along this path, and I want my stick figure to go along that path. All right, so that's where our knowledge of linear equations are going to come into play. All right, but you'll see here, every time I click on a sprite, it's changing the backdrop, the costume function. It's also changing the coding page, the block coding page. All right. So whatever coding I put on this page is only going to apply to this character. Whatever coding I put on this page will only apply to this character. All right. So the first thing I would want to do is indicate when I want the movement to start in the block coding. So under events, you see when the green flag is clicked. I always like to go with that as my way of initiating things. All right, just you start the program and everything starts moving immediately. There's no need to set up instructions for the individual that's running the program, because you can say, like, when the space bar is pressed, things like that. They run the program, and then it's like when the space bar is pressed. But then you got to ask yourself, how is your user, the person using your program, going to know to press the space bar? You'd have to put that in some set of instructions. All right. So unless you want to do that, you probably just want to have things automated. All right. So you'll notice that there are X values and Y values here. All right. These are positions along the graph. So when I drag my sprite, it changes the location along the graph. All right. So what I'm going to do is I'm going to position it where I want it to start its movement. All right. I'm going to have it so it's kind of like walking up the line, ideally anyway. So I'm going to say my stick figure is going to start at negative 90, negative 156. Yeah. Then I'm going to drag it to where I want it to stop its movement. All right, because you have to remember that ultimately, yeah, I mean, we're playing around with coding, and there are some functions that'll create a linear movement, but this is ultimately a math class, and we have to get our math skills in there. All right, so yeah, I can have it glide to a particular location using the glide function, but there's no math there. All right, so I can't give you credit in the math class if you don't have any math in your submission. All right. Also, we're gonna come back to this when we learn about curves. We're gonna learn about several different types of curves in this course. All right, parabolas, cubic functions. We'll get into other types of non-curved functions, but they won't be linear. You know, we'll get into piecewise functions, and it won't be a simple matter of just saying go to this point and everything's fine. All right, so we want to make sure we're using this technique. All right, so essentially, I'm going to be asking for this work. All right, so that's one of the reasons why I'm recording this. All right, so I wanted it to start at negative 90, negative 156. I want it to end up at 56, 144. All right. So if I want to write the equation of a line passing through 2 points, I need 2 pieces of information. I need a slope and I need a y-intercept. All right, slope is change in y over change in x. All right, so negative 156 minus 144 over negative 90 minus 56. I'm doing this off camera. Slowly, apparently. All right, I'm gonna convert it to fraction form and leave it as a fraction, just so I don't have to worry about rounding. I don't expect the numbers to be too nice. All right, so 150 over 73. If you want to know the decimal value, it's approximately 2.0548. All right, but we want to go with this value. All right, at least for now. All right, if you put a really accurate decimal into Scratch, then you would be fine. All right, so if you want to use a decimal, that's fine. Just put as many digits as it'll allow. So the full decimal answer, 479452055. You'd want to get all that in there. All right, because even the smallest degree of inaccuracy is going to impact the movement of the figure. All right, it may not seem like it, but when you're really observing, it'll be pretty obvious. All right, so I have a slope. I can't pull a y-intercept from this. All right, I mean, I suppose I could go to Desmos, plot some points, connect, and just eyeball the y-intercept, but I wouldn't want to do that either. What I would do instead is use the point slope form of a linear function. To write the equation of a line. All right. So that point slope form is y equals m times x minus x sub 1 plus y sub 1. It's a weird looking formula, but it's a very user-friendly formula once you get past the weirdness. All right, it's actually very intimidating to look at, but if you understand that the y and x are built into the formula, we don't substitute in for those values. All right, those get left alone. The m, well, we already figured out the m. The m is the slope. The x1, y1 is some point along the line. All right, so x1, y1 is some point along the line itself. Then you realize, once you think that through, you realize we already have everything we need to write the equation of the line in this form. All right. So my equation here, and I actually have two choices for which one I can call x1, y1 negative 90, negative 156. I could call x1, y1 56, 144. I could go either way. Or maybe some third point that I know is on the line. I don't know a third point on the line, but maybe you do. All right, and maybe a nicer point. All right, but what I'll do here is I'll let x1 be equal to 56 and y1 be equal to 144 because I'm going to snag this ordered pair. All right, so my equation would be, if my pen works, y equals 150 over 73 parentheses x minus 56 plus 144. All right, so that would be the equation of the line passing through those 2 points. Now, what makes this really frustrating, confusing, annoying, other words with negative connotations, is the fact that you may have seen me put this in. When I typed these equations into Desmos, it was just simply y equals 2x, y equals negative 2x. And you might be looking at this saying, well, how on earth did that become y equals 150 over 73 times x minus 56 plus 144? And that has to do with the pixel values in Scratch compared to what 1 unit is considered in Desmos. In Desmos, I'll just put the grid back on. It's your standard 1 box equals 1 unit, all right? But the question would be, how many pixels make up 1 box, all right? Scratch is going by pixels, location within the canvas. Desmos is going by units, and they don't necessarily agree with one another, all right? So what I would first want to do, when I hit the green jammy here, the green flag, is I would want to make sure that my character goes to his starting location. All right. So I could try to drag it, or I can just type in negative 90, negative 156. All right. So I'm comfortable with that. Now, if I go to motion, you see that there's options to go to. All right. It's automatically populated with the coordinate value of the position of your sprite. All right, so what I like to do, instead of worrying about dragging this block out and then typing in the location I want it to go, drag the sprite to the location I want it to go, then pull this out, it'll already have the numbers in. All right, one way or another, I got to get that information in there, but I find it to be a little easier this way. All right, but what I also have to do is define some variables. All right, because, like, where's my x? You go down the line here. Where do I put in? It says mouse x, mouse y. Okay, where's the thing that says let x equal this, let y equal that? There's no option for that. So I go down to variables. Now they give you one called my variable. That's so helpful. We'll create our own variable. Make a variable, and we'll call it x. All right. Now, it has that little checkbox by default next to it. That just brings up the x value in the upper left-hand corner of the screen to see what x is defined as. All right, I also need a variable y, so make a variable y. You see the same thing happens there. I know it's a little small. Let me see if I can bring it in a little bit. All right. See, it's defined as x and y equal to 0. But I have x as negative 90 and y is equal to negative 156. That's a disagreement. And the reason why there's a disagreement is because this x and this and this y are different from this x and this y. They're not the same variables. I just created two new variables, but Desmos is like, Desmos, I'm going to keep saying that. Scratch is saying, well, we already have an x, and that's not our x. You have your x, we have our x. They're not the same thing. So whatever you do with these x values, they do not apply to ours, unless you tell us how to use your information, your x value information. All right. So what I would do is set. So I pull this block out, set x to be equal to negative 90. I believe that was the first value. Yeah, negative 90. All right. So now I'm taking my x value. When I hit that green arrow, that's 0, and there's no point in hitting it now because that's the only thing it would do. It's going to make the x value equal to negative 90. All right. So now there's consistency. It's not going to do anything beyond that, but that's information. All right. That's information that Scratch can use. Okay. Now your x is negative 90. My x is negative 90. All right. Cool. Now what? All right. Well, I want a relationship between my x value and my y value that will then translate to the same relationship between their x value and their y value. All right. So I want, well, it's the equation part of it. All right. I'm going to set my y. I'm going to bring this over. Set my y to be equal to this whole expression. All right, 150 over 73, or the decimal version if it's easier, times x minus 56 plus 144. All right, the issue that we're going to run into is you can't just type that in here. All right, Scratch is going to have no idea what the hell you're talking about. All right, what we need to do is use the operators, the green operators. See, we got some pluses, we got some minuses. So using those pluses and minuses, we're going to build this expression. So I'm going to pull a plus. I have a minus, and I have a product. All right, the parentheses are it's a product. All right, contained within the product is the subtraction. All right. This is order of operations. Each little, they call them pills. Each little pill is a set of parentheses. Whatever happens in there is contained within that expression. Now, to get these two pills combined, you take the left edge of the pill and drag it into the open, well, it's really kind of an ellipse, the open ellipse that you want it to go into. All right. If you try to do it with the right side, the top is kind of like a little iffy, but sometimes it gets a little confused. Like you're trying to get it into this one, but then you keep grabbing that one. But if you use the left edge of it, I want it to go into this one. Use the left edge, you can predict more where it's going to end up. All right. So this is something multiplied by a difference. All right. I would want that entire result to be added to the 144 at the end. So this would be my expression. Now, this is really hard to see, so I'm going to try to zoom it in a lot. The zooming in is never my problem. It's the part where I could then navigate to the thing that I just zoomed in on. All right, well, there we go. Because I'm in the canvas now. Let me get on the blue. Okay. This is actually pretty important. Because what'll happen is when people start trying to move the combined pill around, they'll be like, all right, well, let me just grab this and drag it. And they're like, oh, what just happened? It came apart. You see we have all these different rings together, but you have the piece that's not a double layer. The one that's the least layered, the part that's the least layered of the pill, the combined pill, the compound pill, if you will, that's what you want to drag it by. So you see this is the operation here is connected to another one. You know, there's a sub pill, the pill within the pill. All right. Then these two are plugged into this one, but this one is the outermost pill. All right. So if you drag it by that, you're good. This one is this is embedded inside another one. So if you drag this, it's going to pull it out. All right. If you drag this one, it's going to pull it out. But if you drag this one, it'll be fine. All right. So it's the one with the least layers.
How do you represent X? Because it will let us only write numbers.
That's the next step. All right. So let me get this back to reasonable sizing here. So I want my relationship to be that y is equal to 150 over 73 parentheses x minus 56 plus 144. All right, the numbers you're good, the variables you got a problem. So what we do to get an x in there is we just drag this x, this variable x, pop it right in where you want it to go. Now you have your x. I can put the 150 over 73 using a division operator in here. I could also just put I think I'll just put the decimal. Oops, I missed the force. Yeah, and again, like I said before, as long as you get the whole decimal in there, you're good. So it's that funky decimal times x minus 56 plus 144. All right, if I take that compound pill and put it in, if it'll let me. See, it's grabbing. I just copied it like 7 times into the other thing. Let me just move this over a little bit. And by the way, I'll get to the backpack in a second. If you create something that you're nervous about, like in the sense that, well, I don't ever want to have to do this again and I don't want to lose it, what you do is you just drag it right down into the backpack. So open that backpack, drag it right down and in. It'll seem like it did nothing, but it'll throw it into your backpack so that it's available for you in the future. All right, so you won't lose it.
Are those all scripts you put down yourself? Like would ours be empty?
Yours would be empty, yep. So this is my equation, and this is a good equation to have. I mean, you want to keep this in your backpack because now anytime I want to write the equation of a line, I have it all structured. It's in the right form. So I would just need a point and a slope, and I just pop it right into this. All right. The issue that we're going to run into is that I have a lot of I have go to this x value, but then I have set x to equal this. I have set y to equal that, but I'm not really telling Scratch to do anything with that information. All right. So that's where we kind of run into a problem. All right. Because, you know, what folks will try to do, a little guess and check. I'll just do this, for example. They hit play, and nothing happens. And you're like, oh, okay, well, obviously I'm missing something. But something good actually did happen. You'll notice that my x and y values are set to the correct value in the upper left-hand corner. My x, I had it set to negative 90. The y is now a corresponding negative 156, which is correct. That's where I wanted it to be. But I never told it to do anything after that. All right. So what I'll have to do is instruct Scratch to move my sprite. All right. So the way I'm going to do that is by using the motion function. All right. But I don't want to use glide. I don't want to use go to. If I were to just say go to the endpoint, it would just jump to the endpoint. Yeah, it might feel like it's moving along a linear path, but I want to control speed, right? I want to control angles and things like that. So it's not gonna work. But what I can do is create a loop function. All right. So under control, I would repeat until. All right. I'm going to repeat until the x value gets to where I want it to go. All right. I want my x value ultimately to be equal to 56. So I'm going to use an equality under operators. Repeat until the x value is equal to 56, because that would be the end of the trip. All right. But the question would be, well, what am I going to repeat? All right. Well, I have this idea that I'm setting the x value to equal negative 90. But then what I want it to do, after it sets the y value to some corresponding number, is I want it to change the x value. All right? I want it to change the x value, go to that new location once it determines the corresponding value of y. All right? So what I would do is go back to motion. You see where it says change x by 10? I'm going to change x by 1. Well, actually, sorry. That's their x. Under variables, you see where it says change my variable by 1? I'm going to change my x by 1. I'm going to take that block. Then I'm going to go to motion and go to, I want it to go to specific coordinates. All right? So you see where it says go to x is negative 90, y is negative 156? Okay, I mean, that's a good place to start, but I actually want it to go to my x value and my y values, the ones that I just computed. So you just kind of play this out logically. The first location was negative 90, negative 156. All right. Then I told Scratch, all right, let's make x negative 90. I'm sorry, negative 90. Then compute the y value that corresponds with that. All right. So that gave us the negative 156. Now I wanted to increase my x value by 1. All right. That's going to move it 1 point to the right. So negative 90 now becomes negative 89. It's going to recompute the corresponding value of y, which is going to give me a new set of coordinates. But I want it to actually go to the location of those new coordinates, x, y. So I increase my x value by 1, moving to the right. By recomputing, it's going to then give me the corresponding value of y, take me to that new location, and then repeat that process until x is equal to 56, at which point this loop is broken and the program ends. All right, following a linear path. All right, if I hit the green flag again, it goes right back to start and does the process over again. All right, it's incredibly difficult to look at this and see that this is exactly what we've been doing in class, talking about domain, range, increasing functions, decreasing functions. I mean, even something as simple as a vertical line test. You know, like we didn't actually have to apply that here, but it needed to be a function because Scratch needs to know that there's a single outcome for the given input. All right. If there's multiple outputs, then it's going to get confused and it's going to break the loop before it's completed. All right, but if you think about it again, we defined our variables. We let x. We basically, I mean, it's a weird way of defining it, but we're basically saying we're letting our x be equal to your x. We're letting our y be equal to your y. Then we're setting the beginning of our domain. That's like a square bracket, right? So we're saying for our stick figure, the domain was negative 90 to 56 with square brackets. All right, setting it at negative 90 and then repeating until x became 56. All right, that's a statement of domain. The range was accounted for by the y function. As I increased my x value by 1, it gave us a corresponding value of y. Now, let's say I wanted this to be 0.5. Change my x by 0.5. It's still making the same movement. It's just doing it at half the speed. All right? So because it's accounting for half an x value each time. So instead of every unit of time producing one full step in x, it's producing only half a step in x. 0.25, much slower. All right? Two, much faster. The only thing you got to be careful about, and this has to do with Scratch, but it's also something that would occur mathematically, it's just we've never crossed this path, is that if there's no mathematical way, based off of the change value that you select, for you to land precisely on your end value, then there's no end to the loop. You'd be in that infinite loop. So let's say, for example, I said negative 90 to positive 56, but by going by fives. If I increase from negative 90 by fives, there's never an instance where I would actually land on the number 56. So when I say repeat until x is equal to 56, this would repeat forever because it will never land on 56. All right. Now, I can account for that by saying repeat until x is greater than 56. X is greater than or equal to 56, things like that. But that's a different conversation for a different day. All right. So we'll get to the fencer tomorrow, but that's a good place to stop, I think. Is find some coordinates, the beginning of the trip and the end of the trip for which the fencer is moving. So this looks like a pretty good starting place. So I'm going to have the fencer start at 79, negative 144. And end, well, let's see. I'm going to have it go on up the line here. I don't want to chop his head off, so I'll put him like right here. That would be negative 71, 152. All right. The x values constitute the domain. All right. So the domain for this function, the linear function that we're going to create, is going to go from the smaller x value to the larger x value, negative 71 to 79. That's actually not going to factor into the coding part of it, but I am going to ask you to indicate information like that in your project submission. Right? Because again, like I said, we're using computer science techniques, but ultimately it's a math project. So we need to get the math in there. All right. So we want to write the equation of the line. In point slope form, passing through the 2 points. All right. So the point slope form of a linear equation is y equals m times x minus x sub 1 plus y sub 1. All right. The m is the slope. The x sub 1, y sub 1, those are a point on the line. So m is slope. X sub 1, y sub 1 is a point on the line. All right. So, yeah.
Negative technology.
Yeah, yeah. So, oh, that's not my lasso. I got to compute the slope because I already have a point on the line. I got 2 points on the line. I can choose either one of them, whichever one I like. And I like the one that typically is cleaner. Cleaner meaning has nicer numbers like 0 or 1 or less negative numbers involved. These are both pretty ugly, so you really can't go wrong either way. So I'll probably just go with the first coordinate, the first ordered pair. I'll let that be x1, y1. All right. So I just need the slope. Slope is change in y over change in x. So negative 144 minus 152, 79 minus, well, minus negative 71. So I'll crunch those numbers off camera here, off screen. Because we don't expect, I mean, this is a real world problem. We don't expect the numbers to work out to be too nice. We're kind of surprised if they do. All right. So this is negative 1 point. Well, actually, there's got to be something wrong. I did something wrong here because it shouldn't be negative. Minus 79, negative 144. So then, I'm just making sure I type. That is so weird. Oh, no, it should be negative, sorry. I'm second guessing myself for no reason, for no good reason. Honestly, I think I tricked myself on something that never should have happened. I'm looking at the fencer going uphill, and I'm like, why is it negative? The line itself is negative. The line's going downhill. His motion up the hill has nothing to do with the slope. All right? I had a senior moment there. All right? So negative 1.973, but if you want to have something cleaner to write down on paper, you could just write it as negative 148 over 75. All right? So the equation of a line, again, we are only substituting in for the m and the x1, y1. We're actually leaving the x and y alone. That's going to be part of our answer. So the x and the y are going to stay put. Everything else changes. All right? So to be particular to the problem. So negative 148 over 75 times x minus 79 plus negative 144, so minus 144. All right, so that's the equation of my line. If I could somehow get that coded in, then my graph will move, or my fencer will move along that line and follow the appropriate path. So now I got to make that happen. All right, so if you have any experience with coding in any capacity, one thing you might know is that the computer won't do anything unless you expressly tell it to. All right? There's no implication. There's no implied action. It's got to be explicit. Right? Everything needs to be spelled out. Detail matters. All right? So the program won't start unless you tell it to start. So for that, we would go to events. All right. You see different options when the green flag is clicked, when space is pressed, when the sprite is clicked, and things like that. I prefer when the green flag is clicked. All right. The reason I like that, especially for beginners, is because if, for example, I select when space is pressed, sounds like a fun little intermediate kind of thing. All right. So, oh yeah, just hit the space bar. That'll be fun. How is your user going to know to hit the space bar? You'll have to put it in the instructions. What if you forget to do that? All right. Here, you don't have to worry about forgetting to do that because you can't run the program without hitting the green flag. All right. So it's a default. So we do that. All right. Then, well, this is where things get interesting. You'll see here that they have X value or an X value and a Y value defined, and that corresponds to a location on the graph. All right, where I put my fencer impacts the X value and the Y value. All right, but I have no way to access that in terms of the coding. There's no if X is equal to this, then Y is equal to that kind of thing. All right. So what we have to do is build that in there. If you go into variables, these weren't there before the X, Y. I put them there. The way you put a variable in is by clicking make a variable. Call it whatever you want. I called it X. I hit OK. And then this came up. All right. Then I clicked it again, make a variable. I typed in Y. I hit OK. And then this came up. All right. So that X value you can see here is not in correspondence to these numbers. All right. In fact, it's in correspondence to these numbers. All right. So, and that's because this is another bit of coding that I did with the other class. So these X values are already kind of accounted for. All right. So this is saying that X is equal to 56, Y is equal to 139 point whatever. If I turn on this program and run it, I have this sprite doing the movement that I want for that action. You know, like I wanted it to move along that line. This code will do that based on how I define my X values and my Y values. All right. But long story short, I've already used X and Y for some other aspect of the program. So if I want to do that, if I want to use X and Y, then I'm going to have a conflict. All right. So the way I handle that is if I have a second sprite, I create a second X. I create a second Y. All right. So what I'll do here, because I've already used X and Y for something else, off screen, off camera, make a variable but call it capital X. All right. Make a variable, call it capital Y. All right. As long as you have new variables for each slide. All right. Or each sprite, I mean. So, but you'll see here, it's still not corresponding with the location of the fencer. The fencer's I have it right now at 76, negative 141. Here it's saying my X value and my Y value is 0, 0. Right? That's not correct. If that were the case, if the X value, Y value were 0, 0, then my fencer would actually be at this location. But my fencer is actually at this location. All right, which is where I want it to be. So somehow I have to get my XY to be in alignment with their XY. All right. Well, before we even get started with that, one thing I can tell Scratch to do is put my fencer at the appropriate starting location, which is to say, have it go to, upon the beginning of the program, have it go to 79, negative 144. You'll notice how the coordinates are automatically populated. Like if I move the sprite, I'll just move it real quick. If I move the sprite, let's say over here, it changes the numbers within the block coding. That's actually a really good feature because it allows me, instead of having to move the sprite, identify the numbers, type it in, I can move the sprite and then just grab the block that I want without having to type in the numbers. All right. So that's a pretty good feature. But what I want Scratch to do is set my X value, my X variable, to be the same as the starting value for the fencer. So again, 79, negative 144 is the starting location. It has an X value of 79. That's what I want this X value to be. I don't want it to be 0. I want it to be equal to 79. So I'm going to set capital X to be equal to 79. All right. Now, just very quickly, I'll run the program. Nothing changed in terms of the position of the fencer because I didn't tell the program to do any of that. But it did set my X value to 79. So that's a win. All right, mission accomplished there. Now that I have that, though, I need to get this relation in here. The negative 148 over 75, X minus 79, blah, blah, blah. All right, but I also need Scratch to move my character to get to that location. All right, so the way we handle that is by creating a loop. All right, so that's under control. We do a repeat until. All right, because ultimately, if I look at my domain, all right, so my domain is negative 71 to 79, but I want it to go backwards. All right, I want it to go from 79 to negative 71. I want whatever my relationship is, whatever my coding is, my command is, to repeat until I've achieved my goal of getting to the X value of negative 71. So we go to operators. I'm going to pull out this one here, this little hexagon, and I'm going to say, yeah, and the reason I know to pull that one out is because if you look at the shape of the opening, it's a hexagon, so I pull the one that looks like a hexagon. All right. I'm going to repeat until my X value, capital X, is equal to negative 71. I'm going to throw that in here. Now, when you're taking one of these, the little operators and the hexagons and things like that, anything that's shaped like an oval or a hexagon, they call them pills for some reason. But even though this one would be a pretty painful one, if you want to put the pill into the opening, you grab it by the operator, whatever it is, the equal sign in this case, drag it, and then place it so that the left edge of the pill goes into the opening. Because if you do it with the right edge, nothing happens. But if you do it with the left edge, you see it lights up, and now you know it'll be a fit. All right. So what I'm going to do is I'm going to repeat the movement that I'm about to create over and over and over again until the X value is negative 71. All right. So back into the variable section, you see we have set X to 79. We already did that. Now I want to set Y, capital Y, to be equal to all of this stuff. Because then that'll give me the Y value that corresponds to the given X values. All right, this is the equation. But again, just by typing this equation, just by putting this command in there, Scratch isn't going to do anything except run the numbers because it doesn't know what you want to do with that information. But I can put these operations in. You see here I have a couple of subtractions and a multiplication. So I go to my operators and grab a couple of subtractions and a multiplication. All right. And I also have a fraction there, so I might as well grab that out there too, because I don't want to put that decimal in. You know, for the other one, the decimal was fine. The stick figure, you can look that one over later. I'm going to post up that video. But this one with the repeating decimal, it's not quite as nice. All right. So, but if I piece this together, I have an X minus 79. So let me grab that. X minus numbers you just type in, variables you need to drag from the variable menu. All right, I got an X minus 79. That's getting multiplied. So I'm going to drag this pill, put its left edge into the right opening for the multiplication. That's getting multiplied by negative 148 over 75. So negative 148 over 75. So I'm going to drag this pill into this. You see, like it starts, what are we doing? But if you get the left edge into that opening, it'll lock in. But then you look at it, and let me just kind of zoom in a little bit. Oh, that's the opposite of in. If you look carefully, you see we have pills within pills. If you want to start dragging this around, you got to be careful about how you drag it. You want to drag it based on the outermost pill, all right? So the one that doesn't have, or the one that has the most stuff in it, all right? So find the operation that represents the outermost pill and drag by that, because if I drag by this, it's going to start breaking it up. Drag by this, it's going to start breaking it up. But if I drag it by the one that is the outermost pill, it'll be fine, all right? Now, all of that minus 144, so I'm going to put this in the left opening here, and then put a 144. The outermost pill here is the minus. Just think about the last operation that you did, and that's usually the outermost pill. All right, I'm going to drag that, and I'm going to pop it in here, and now I have an equation. All right, y, it says set y2, but that's really saying y equals negative 148 over 75 times x minus 79 minus 144. All right. So if I put that into my repeat, it'll do a computation. I'll hit play here. It just made that computation. It didn't do anything though. It went to the starting point. It made the computation, then it just stopped. All right, but you can see the y value is what it ought to be, negative 144. That's great. Now I want a movement. I want some kind of change. So I want my fencer to start moving to the left. As it moves to the left, I want it to follow the line, which means I also want it to move up. All right? But the y equation that I just put in, that is the line. So if I tell it to move to the left while also following the line, then it's going to go where I want it to go. The way I get it to start moving to the left is by using the change operator. Well, it's not really an operator, but under variables, it really is. It is an operation. It's a movement operation, but it's in the variables category. Change the capital X variable by -1 because I want it to go to the left. All right. And so it'll make changes, but I still haven't told it to move anywhere. So if I run the program, it'll do stuff. But I mean, do stuff in terms of computation, but it's not going to do stuff in terms of real movement. All right. So that didn't get the job done. However, if I go to motion, you'll see there's an option to go to. All right. Go to x equals 79, y equals negative 144. That's not really helpful. But if I have it go to whatever x is at any moment in time and whatever y is at any moment in time, just think about it. You carry out the operation. Its first move is to set x to equal to capital X to be equal to 79. All right. And then it spits out a corresponding value of y. All right. Now, if I tell it to go to that location, that would bring us to our starting point. All right. Then if I reduce the x value by 1, 79 becomes 78. It spits out a y value based off the equation. I have it go to that new coordinate. All right. Then reduce the x value by 1, plug it into the equation. It spits out a new y value. I have it go to that new coordinate, and so on until we arrive at an x value, capital X value of negative 71. So, and that's the repeat until. So it'll complete this loop once the x value gets down to a negative 71. So once x got to a negative 71, it stopped, and we're good. It stayed within the domain of negative 71 to 79, just went backwards. All right, it followed the equation of the line, but now I have some flexibility because, we're talking about those story graphs. What if I said on one piece of the trip, the fencer was going twice as fast as the second piece of the trip? That would be a change in the x value, for example, or the slope. Depends on how it's structured. But let's say I make my change x by, make that a negative 2. Now it's going faster. Negative 3. Well, actually, I'll make it negative 5 so I could show you what happens. If I make it negative 5, it goes super fast. But then you'll see, well, actually, it's not even. Wait, is that a multiple of 5 somehow? Let me do negative 10. Huh, it stopped. Okay. No, because sometimes it ends up in an infinite loop, because if it doesn't actually land on the negative 71, then it keeps going on forever. But this one, I guess, is fine. I don't know why. All right, and so there we go. All right, it's making the correct movement, and I'll just bring it back. We could even go fraction form, so like negative 0.25. Much slower. All right, so all of those different things come into play. Now, like I said before, I went with the fraction value here, the negative 148 over 75. Maybe that's too much of a pain. If you have a reasonable approximation of the decimal value, you could just put it in. It was negative 1.973 repeated, so let's just get a bunch of 3s in there. It's still following the same path. Hit stop if you want to interrupt it, and oops, get back in there. Hit stop, interrupt it if you want to change a setting on it, but we're in pretty good shape here, So it's doing what we want it to do. Now I have, again, my other sprite from the other class. This one is following a different line, all right? So it's starting on the lower left and going to the upper right, but you can see the structure is the same, except I have my change in x. I had it at a 2, but it was a positive number, all right? That's because I wanted it to go to the right. All right, but you can see we came up with an equation, put it in decimal form. We had a repeat until, we changed, we went to, we had some starting point, but it's essentially the same idea. All right. So you can have multiple graphs going at the same time, or multiple sprites going at the same time. All right, but in this case, you'll notice how I used a lowercase x and an uppercase x. Let's say, for example, if I change them, two lowercase x's versus an uppercase x. But let's say I changed them so that they had the same type of variable. Now we have some conflicting program that's not doing what I want it to do. All right, because it's getting confused. It doesn't know. I have my program telling it to do 2 sets of different things with the same variables, because it's not a function. It has different outputs for the same input. All right, it doesn't pass the vertical line test. So that's why we needed different variables. All right, because it has to be a function. All right, but once you do that, everything works the way you want it to. And you don't really have to use x and y. You could use stick x, stick y, fence x, fence y. Like you can do it that way too. All right. So in the stage area, that backdrop, I wanted that to be just a line, because I want to show you how you can move a sprite along some predetermined line. All right. So yeah, actually, let me do a different line, because I just realized that's the one I did with period 1. So I want something unique to us. So let's say y equals 1, third or 1/3 X. You know, something kind of simple. Get rid of this stuff. All right, so let me do that. I'll upload my new and improved screenshot, and that'll be my backdrop. All right, so what I want to do is have a character move along this line. All right, now what you're going to do when we actually get to the project is you're going to, if you remember the quiz, which I'm still grading, and there's some folks that need to take it, so I'm just playing the waiting game. But you remember there were different line segments that made up a story. They call them story graphs. Very creative, but it would go up, it would go down, and maybe it was constant. You're going to get a graph along those lines, and you're going to have to animate a sprite along that graph, right? And account for things like domain and range and all that good stuff in a creative way. Right? So knowing how I'm expecting you to graph a line is pretty important. All right. So yeah, or at least a linear path. But again, we don't want to have just the preloaded sprites. We want this to be as authentic as possible. All right. So we don't want to use the preloaded linear movements. We want to do it all ourselves. All right. So, but what I will allow for is that you don't have to hand draw a sprite. I mean, if you can, if you're that artistic that you can come up with something really nice and do it by actually drawing it, that's great. I mean, that's even better, but I can't, so I wouldn't expect you to do that. All right, so in terms of coming up with a sprite, you would just look for some image that you would modify, all right, but you wouldn't use the ones that are preloaded in Scratch. So you go to Google, find the image of some sort of character that you'd like to animate, all right? So, I don't know. Let's say hockey player. All right, here's hoping nothing weird comes up. All right. It's a pretty solid one. There's a lot of stuff going on in this picture, but that's all right. So I'd save it. Now, I was told earlier today that, a 6-tool player apparently. Good to know. That if you use a PNG file, that you don't have to worry about erasing backgrounds. Well, I didn't know that, so here we are. All right, so I upload my sprite. It's my not a screenshot. It's the thing I just downloaded. 6-tool player. Open. It's like massive. It's way too big, but I got some work to do on this anyway. So I go to costumes, and I'm just gonna get rid of all the fluff here. So I'll click on the eraser. I'm gonna increase the size of the eraser because I'll do like a quick once over. Get rid of all the easy to get rid of stuff, and then I'll come back and fine tune it. But start with this. And if you could do the job with like a massive eraser, then it'll save you the time and energy, but I generally never am able to, because it looks like that, which is really not that good. So let me go back to like 40. I'm going to zoom in and start fine-tuning a little bit. Doesn't have to be perfect, but I want to be able to look at my character when I'm done and say, okay, definitely hockey player. All right, so that's really what I'm at. Got to make sure those skates are visible. Like in this area here, if I round it out, that's not a big deal. So cleaning it up, cleaning it up. I'm going to go back to an ordinary zoom, take another look. Okay, it's maybe a little too rounded, but that's all right. All right, but I am going to reduce the size of my eraser, make it a little bit smaller. All right, so a little bit better. Maybe around the stick a little bit more. But I'm pretty comfortable with the way this looks at this point. All right, still on the big side, so I want to reduce that down. So I'd go into, well, first, before I even do that, I'm gonna kind of lock this in by going back to code so I don't accidentally erase more than I should. But then my size, I'm gonna take that down to like 25 and see what it looks like. All right, that's a little bit better. All right. And besides, when you shrink it down, you start hiding all the little imperfections along the way, and it's okay. We need it to be relatively small, otherwise it's going to dominate the figure, or the image. So now I want to animate this thing. All right. But in order to do that, I need to write the equation of a line. All right. So we need to write the equation of the linear path in point slope form. And what I mean by that is using the formula y equals m times x minus x sub 1 plus y sub 1, I want to write the equation of a line. The m is the slope. The x1, y1 is a point on the line. All right, so what I'm going to do is I'm going to identify a coordinate where this hockey player is going to start his journey, and I'm going to identify a location where he ends his journey. All right, so I want him basically skating up this line. So negative 207, negative 55. You can see it in a little, I mean, it's small on the big screen, but if you look carefully, you can see the coordinates for where he's located at this moment are negative 207, negative 55. And if he were to follow this path, he would eventually end up, well, I don't want him to go completely, well, I don't want him to go off the screen at all. So I'd have him finish up his trip over here at 122.54. All right, so I need to find the slope of the line connecting those 2 points. Slope is change in y over change in x. So negative 55 minus 54 over negative 207 minus 122. All right, so I'm going to crunch those numbers just kind of off the screen here. I'm just going to move this over a little bit. All right, so that's going to be negative 55 minus 54 on top of the fraction. So again, it's just crunching numbers, so I'm just doing this off camera real quick. You get a fractional value of 109 over 329. But you also can get an approximate decimal value, 3.331306990881. All right. You're going to want the entire decimal, otherwise your character is going to go off the rails a little bit. All right. So we needed a point. We have 2 points. We needed a slope. We have our slope. So now I'm going to plug that information into my point slope form. My slope will get replaced with either this number or this number. It really doesn't matter. All right. but that's what the m's getting replaced with. The x1, well, I got to decide which coordinate I want to work with. Personally, I like the one that's got cleaner values. So in this case, it means the ones, or the one that involves less negative numbers. So this number would go in for x1, and this number would go in for y1. Right? So once you decide on the coordinate that you want to call x1, y1, the x value of that coordinate is x1. The y value of that coordinate is y1. Right? So I would say as my equation, y equals, well, that funky decimal, which I really don't want to write. So I'm going to write the 109 over 329, x minus 122 plus 54. All right. So that's the equation of the line. Now, you might remember when I actually plotted this on Desmos, I did not plot 109 divided by 329 times x minus 122 plus 54. I just plotted y equals 1/3 x. Now, the issue is that was based off of the scale that Desmos uses. This is a completely different scale based off of the pixels and location within the canvas that Scratch uses. All right, but I need to somehow get this equation into the coding editor. All right, so the first thing I would want the program to do when I run it would be to actually run. All right, so that would be under events. I would select some way of activating the code. All right, and that would be when the green flag is clicked. Right, that's my preference. I mean, there's things like when the space bar is clicked. I mean, if you hit that little drop down, you see all these different options, up arrow, down arrow, and all that. The issue with those things is that you would need to tell the user of your program that they need to do that. So you'd have to write instructions. All right. This, just using the green flag, helps you avoid writing instructions. All right. So I want my program to place my hockey player at the starting location, which is at coordinates -207, -55, over here somewhere. You know, I was very kind of careful about trying to get it into that location here. If I try to place it with the mouse, I mean, I get close, but not quite. So I'll just type it in, -207, -55. And that places it where I had it before. All right. But the good thing about it is when you go to motion, you see all these different options. One of them is go to x equals y equals, or x colon y colon. It auto-populates the values in those fields, bless you, with whatever the location of the sprite is at that moment. All right. So if I have my hockey player anywhere, and I have this little bit of code in here, this block, if I hit the green flag, it's going to take my sprite and put it to the starting location. All right. So that's good. All right. So we know that anytime we run the program, the hockey player is going to go to where he's supposed to go initially. All right. Now I need him to actually move. The issue is I have an equation here that involves y's and x's, and they have a y and an x here, and my numbers are based off their numbers, but there's no function in here that tells you or allows you to say, put in y equals 109 over 329, blah, blah, blah. There's no way to write an equation without defining variables first. So to do that, we go to the variables section. All right. So in the variable section, you see there's only one variable indicated there. It's called my variable. I don't want a variable called my variable. So I'm going to make a variable and call it x. All right. Now you can make this variable for all sprites, but you kind of run into an issue there. I'll explain that in a sec. Or you can make it for this sprite only. All right, we're going to make it for this sprite only. So now I have a variable x, and you could see it says 6 tool player. That's the name of the the sprite. I mean, I could change the name of the sprite if I want, but the 6-tool player sprite, the X value associated with just that. All right. The reason why, and I'll make a variable for Y also, for this sprite only. The reason why you don't want to do it for all sprites is because when you define a relationship between X and Y for one sprite, and then try to define a relationship between X and Y for another sprite, you end up with a function conflict, all right? Because one sprite is defining Y to be a particular number, another sprite is telling the program, or the program is telling us that another sprite is indicating that the Y value is something else. All right, we know that for one input, we should only have one output. All right, if we don't select for this sprite only, one input could lead us to multiple outputs, and because of that, you'll get a break in the program or some inconsistency, which makes your program not run the way you want it to. All right, so you want to select for this sprite only. All right, there's other ways to handle it if you select for all sprites accidentally, but that's not the recommended way. All right, so what I'm going to do, we have the sprite going to the initial location. I'm going to set my variable X to be equal to the X value at that initial location. So I'm going to take this block out here, set X to -207. All right. So slowly but surely, we're getting on the same page with Scratch. All right. So I just created a variable. I'm making my variable the same value that Scratch is making their variable. We're both calling our variable X. Their X means one thing, my X means something else, but now this is the first step towards our variables meaning the same thing. All right. So I'd connect that. And if you run the program, you see absolutely nothing happens in terms of the animation, but 6-tool player X is now valued, instead of being valued at 0, which is not what we wanted, it's now valued at -207, which is exactly what we want. All right. But then what I want to do is I want to create a relationship between Y and the variable X. All right. So I'm going to set Y to be equal to all of this stuff. All right. But the thing is, we have to use the preloaded operators that are installed in Scratch in order to do that. So we go to operators. That's the green section. You see we have addition, subtraction, multiplication, division. All right. In this equation, I have division, multiplication, subtraction, and addition. So I'm going to need each one of these. They call them pills because I guess that's what they're shaped like. But I figure they could have come up with a better name for that, but it is what it is. All right. So I have a fraction 109 divided by 329. I'll show you another way to handle the slope in a few minutes. All right. That's getting multiplied by x minus 22. So let me grab the minus pill. All right. You don't just type in a variable. You actually have to pull it from the variable section. All right. So when I want to put in x minus 22 to address these parentheses, I would pull the x here, from here, and put it into the pill, and then type in the 122. All right. So that's kind of a weird thing. You would think that if you can do it for the numbers, you should be able to do it for the letters. But that's only because we created blocks to represent the variables, and those blocks are already defined. They're encoded. All right. So Scratch knows that if you use those, they've already been predefined and they're ready to go. All right. So I know based on my equation here that I'm taking this quotient here and multiplying it by the x minus 22. So I'm going to use the multiplication pill. I'm going to put my quotient in the first opening, and I'm going to put the subtraction in the second opening. When you're inserting a pill into another pill, you want to do it by the left edge of the pill, the one that you're trying to insert. If you try to do it with the right side, nothing happens. You try to put it in, nothing happens. But if you do it on the left side, you kind of look at that as, all right, I want this to go into this opening or this opening. If you do it by the left side, it's clear which one you're going in for. All right, so between the two. But if you try to do it on the right side, nothing happens, and it could even get confusing. So unless you want to do the whole guesswork thing, it's like, oh, okay, well, I'll just keep hovering over it until it's the one that I want. You could do that too, but I'm using a mouse, and that's fine. That's easy enough. I know using a trackpad, it's not as user-friendly. All right. So that pill would go in the first opening. This pill goes in the second opening. And now I have the 109 divided by 329 multiplied by the operation x minus 122. I'm going to add that to the 54. So I'm going to take that expression and put it in the addition pill. All right. In the first opening, in the second opening, I'm just going to type the 54. All right. You just got to be careful when you're moving the compound. I call them compound pills. I don't know what they're actually called, but pills within the pills. If you're moving them around, if you grab it by the wrong thing, it'll start breaking it apart. It's kind of annoying. So I'm just going to zoom in real quick. If you look carefully, you see that you have like the multi-level pills here. You get a pill within a pill within a pill. You want the outermost pill. All right. If you're going to drag, you drag by the outermost. Because if I grab by this one, it breaks it apart. If I grab by this one, it breaks it apart. But if I grab it by the outermost one, the one that's got the least amount of stuff going on, then it'll move everything around. All right. The whole thing as a cluster. All right. So I want this mega pill to go into the set y to 0 thing. All right, so I'll grab it by the plus sign, left edge into the y, set y2, and now I have an equation. All right, that is my equation that will define y in terms of x. So if I take that and connect it and run the program, it's still not going to move anywhere. But now if you look in the upper left-hand corner, you see that my x value and my y value are what they should be. Negative 207, negative 55. So I have a correct relationship. The issue is when you write a program, you have to be very explicit. It's sort of like, well, I don't know how many of you are familiar with like basic programming, like programming called BASIC, where you can have it do computations, but if you don't tell it to display the result of the computation, it won't do that. All right? So if I tell a program to compute 5 times 4, most of the time it'll say something like done. I'll say 5 times 4, run the program, it'll say done. Because it multiplied 5 by 4. If I ask you, figure out what 5 times 4 is, there's an implication that I'd like you to tell me what that answer is, but I wasn't explicit. So if I said figure out what 5 times 4 is, you might say, okay. And then if I were to turn around and say, and what is it? You might react like, you didn't tell me that you wanted me to say it. You just said figure it out. I figured it out. Why are you getting all angry with me? Like that kind of thing. All right, that's how programming works. All right, so I just told it to figure out what y was. I didn't tell it to do anything with that information. So that's where the next step comes into play. All right, so I'm going to break this off. And by the way, if you want to break off a piece of coding, you break it off by the bottom piece, not the top piece. So if I wanted to move these things around, I'd grab it by the highest part of the block. But if I wanted to disconnect these two, for example, I'd pull the blue. All right, I wouldn't pull the orange or light orange or whatever it is. All right, so I'm going to pull off that last block and just kind of put it on the side. And by the way, the backpack is a pretty good resource. If you click on that, let's say you put a lot of effort into creating a set of code, a nice block, and it took a little while to do. Throw it in your backpack. Yours should be empty at this point, but those, I have in my backpack now, I have this block of code that I can now go and retrieve. The most recent is always in the beginning. All right. So that's something. Now, if you need to get rid of a block, then just drag it over into the command code field. I don't even know what it's called, but this area, this neighborhood, and it'll wipe it out. All right. But what I want essentially to do here is have Scratch actually move my hockey player based off of this equation. All right. So I might look in the motion. I mean, that's probably not a terrible idea, but what I need to do is manipulate my variable. All right. Because my variable needs to change in some capacity. All right. So what I'm going to do is I'm going to actually have my X value change by 1 unit. All right. And when I do that, it'll go from an X value of negative 207 to a negative 206. And then I would want it to recompute the Y value and plot a point at that location and then move my character to that point. All right. But I want it to happen over and over again. I don't want it to just go 1 point at a time with me creating blocks every step of the way. I want it to repeat that operation. I want it to increase my X value by 1, come up with the Y value, move to the new location, and then do it again until it runs out of space. All right, so for that, I would go to Control. You see that there's an option to repeat until. This is a loop. All right, it's a finite loop. All right, we don't want it to go on forever. We want it to stop at a certain point. But I have my X value set at negative 207. I want this operation to continue until I get an X value of 122. So you see the hexagonal opening here? If you go into your operators, you see hexagon-shaped blocks. All right. So I want to select the one with an equal sign and tell Scratch that I want to repeat until X is equal to 122. So then the question is, well, what do we want it to repeat? I want it to find the Y based off of the X value I start with. Then I want it to actually go to that location. All right. So I have an X value that I'm starting with, negative 207. It figured out the Y value corresponding with that. All right. So I want it to go to that location. So I'm going to choose the go to X, Y function again. But this time I'm going to put in an X and a Y, my variable X and Y, telling Scratch that once you compute the Y based off of the X value that's given, go there. All right, that's what this will do. Then once you do that, increase the X value by 1, figure out the Y that corresponds with that X, then go there. Increase again the X by 1, figure out the Y corresponding with that X, then go there. And keep going there until you get to an X value of 122. At which point you break the loop and the hockey player should come to a stop. All right, so we arrived at an X value of 122. The Y value was pretty close. I mean, it would round to the 54, so I'm pretty comfortable with that value. All right, and it followed the correct path. All right, do it again, hit the green flag again, just to make sure that it's going to go back to where it's supposed to start and complete the trip the right way. All right. I mentioned before that you wouldn't necessarily have to use the fraction. You know, the 109 divided by 329, you could type in the decimal. Let me just show you that real quick. If you do that, 331,306, 990,881. That's a decimal equivalent. Should do the same thing. All right. Now we changed the x value by 1. You know, in those story graphs, you know, sometimes the character's going a little faster. You know, realized he forgot something at home, ran home to get it. Instead of walking home. Started off walking, started running, then came to a stop. So maybe you want to speed up your character. So maybe instead of changing my x value by 1, I change it by 2. Let me go a little bit more dramatic. 4. All right? Much faster. All right? But you'll notice that the ticker at the top, it's not stopping. I accidentally created what's called an infinite loop. All right? We're stuck in a time loop, basically. Because what's happening here is this. Is there like an early dismissal? Okay, well, whatever. Anyway, so because we're starting off at negative 207 and stopping at 122, if I'm increasing by 4, I'm always going to end up with a odd x value, which will never actually allow me to land on a 122. So it never satisfies the criteria of having x equal 122, which means that it'll never stop the loop. All right? So you got to make sure that whatever number you select will actually allow it to land on the repeat until number. But if I go back to something like 1, or even if I go to a fraction value like 0.5, it'll work, but you can also manipulate the speed that way. All right? So a lot of stuff going on here.